Hi everyone. In this video we're going to talk about how we can solve exponential equations using logarithms. So we've built up all this material around logarithms, and we've seen that they are the inverse of the exponential function. And so in this video we're going to see how we can use that as a tool. So a lot of different situations can be modeled using exponential functions, and we can use the logarithm as a tool to help us answer different questions that surround exponential models. All right, so what I am going to do is start with an example here. So we're going to look at 3 different examples through this video, and we're going to see if we can come up with some common procedure to help us solve these exponential functions. So the first one that I want to solve is e to the 2x is equal to 25. So here is an exponential equation. So if you'll remember, this e is a number. So just as a reminder to us here, we want to remind ourselves that e is approximately 2.718. Okay, so e is kind of like pi in the sense that we're using a symbol in place for a special number. So e is 2.718, and we just want to remember that. So it's a number, and it's the base. It's also the base of the natural logarithm. Okay, so e to the 2x equals 25. The structure that I have here is on one side of my equation, I have just my exponential function. So I have a single exponential function on one side, and then I have a number on the other. So if you recall, when we were solving logarithmic equations, what we wanted is we wanted a logarithm to be on one side of the equation, and we wanted a number to be on the other. This is similar to that, except in this case, we're always going to want a single exponential equation on one side, and then we're going to have our number on the other, or our other terms on the other side. Right, so if we can get to this point, then we're in really good shape because we can use what we know about logarithms. So the general procedure goes something like this. So I'm going to have my equation set up. So I'm going to try to get it into this form. And once I'm here, what I can do is I can use the natural logarithm, or really any logarithm, to get this exponent down. So the problem that I'm having right now is if I think about this, I want to get to this x, but I can't, right? So it's in the exponent, so I need to somehow get it out of the exponent so I can deal with it. And one of the great things we have is we have a rule for logarithms that says if I have an exponent, what I can do is I can bring it down as multiplication. So what I'm going to do is I'm going to take the natural log of both sides of this equation. And so what I end up with is, on the left-hand side, I get the natural log of e to the 2x is equal to the natural log of 25. Okay, so if you recall ln, so this is an L and an N, so it stands for natural log, and the base of the logarithm is e. Okay, so this is great. I'm actually in great shape right now because if I remember my rules for logarithms, what they tell me is I can take this exponent, so I can take this 2x as the exponent, and I can bring it down outside. So I can bring it down outside like this, and what I would end up with is 2x times the natural log of e is equal to the natural log of 25. All right, so what I would have to do here is I need to get this x by itself. And what I can do is I notice that I have a 2 here and I have a natural log of e. And really what I would like to do is get this x by itself. So I'm going to take both sides of this equation. I'm going to divide by 2 times the natural log of e. And on the right-hand side, I'm going to divide by 2 times the natural log of e over here. And what ends up happening is on the left-hand side, most of this stuff ends up canceling out. So if we see here, my 2's are going to cancel, right? So these 2's are going to cancel, and then the natural log of e's are going to cancel, and I'm just going to be left on the left-hand side with x, and that's going to be equal to the natural log of 25 divided by 2 times the natural log of e. Right, so if we wanted to, we could totally just leave our answer like this. This is a number, so if we really wanted to know a decimal approximation for this number, we could use a calculator, something like Desmos, but we don't have to. We can leave it just like this. If we wanted to take it one step further, I could rewrite this and say this is just the natural log of 25 divided by 2. Okay, so when we look at this, the natural log of e, so ln of e, the natural log has base e, so we talked about e up here. So this is a question that's asking us, e raised to what power is e? And the answer to that question is 1. And so the natural log of e is just 1, and we can simplify to this. Right, so x is the natural log of 25 divided by 2 would be the solution to this exponential equation. Right, so something to get familiar with is equations that look like this, so having the natural log in there is very common in solutions to exponential equations. All right. So what I'll do is I'll clean this up, we'll come back and we'll look at another example. All right, so we are back and we have another example in front of us. So this one is a little bit more complicated because I'm thinking about the form that I want to get an equation of like this into, and I would really like to have my exponential, a single exponential equation on one side and everything else on the other side. So the first thing I'm going to do here is clean this up a little bit. I'm going to take this 7 and I'm going to put it over onto the other side. And what I get is 8 to the 3x minus 5 is equal to 15. Okay, so this is a great first step for me because now I have my exponential equation on one side and I just have a number on the other. All right, so the same problem that I had with the last example was I have this x, I'm going to try to get to this x up here in the exponent, but I don't know how to do that. So what I need the help of the logarithm. So what I'm going to do is I'm going to end up taking the natural log of both sides of this equation. I'm going to end up taking the natural log of both sides of the equation so that I can use my rule for logarithms. All right, so I get natural log of 8 to the 3x minus 5, that's all in the exponent, is equal to the natural log of 15. Okay. So I did this for a very particular reason. So when I take the natural log of both sides, I'm doing this because I really would like to take this exponent and bring it down out front. So what I'm going to do is I need to take that 3x minus 5 and multiply it by everything. So when I do this, I get 3x minus 5 times the natural log of 8. So notice that I put parentheses around the 3x minus 5. That was important because 3x minus 5, that entire thing is getting multiplied by the natural log of 8. And then on my right-hand side, it looks like nothing changed. So one question that you might have at this point is, why did I use natural log? And the answer is because it was less writing. So I can use any base logarithm that I would like. If you wanted to, what you could do is you could use log base 8, and then you would get a nice cancellation property happening like we did in the other example. But as mathematicians, we typically use natural log for everything. So through the change of base formula, we've seen that we can change our base if we need to, and so natural log is less writing. It's only 2 letters, so I use it more often. But it's not important which base you use, so I just like to stick with natural log. All right, so with that aside, what we're going to do is we come back and we ask ourselves, how do I get to this x? And I'm going to start undoing things. So I just have to start bringing things over to the right-hand side of this equation and get my x by itself. So step one is going to be to divide both sides by the natural log of 8. All right, so if I divide on the left by the natural log of 8, and I divide on the right by the natural log of 8. Okay, so what we're going to do is we're going to come up here, and the natural log of 8's cancel, and I'm left with 3x minus 5 is equal to the natural log of 15 divided by the natural log of 8. And so we're in pretty good shape here. You might be intimidated that this is a lot of symbols over here, but always keep in mind that this is just a number. So if I ever wanted the decimal approximation for this, what I could do is use a calculator. I could use Desmos. It would tell me what it is. But I don't need that. So up to this point, this is the exact answer. And any decimal approximation is not going to be exact. Okay, so if we keep going, I still have in my mind, my goal is to get that x by itself. So the next thing I need to do is get this 5 over to the other side. So I get 3x is equal to the natural log of 15 divided by the natural log of 8 plus 5. All right, so one final step. I just need to divide both sides of this thing by 3, or if you wanted to, you could multiply by 1/3. And what we end up with is x is equal to this entire thing, the natural log of 15 divided by the natural log of 8 plus 5. This whole thing all divided by 3. And so this right here is my exact answer. Now, it might not look like an answer to you because you say this isn't a number, but remember that it is. Everything over here, there's no variables, there's no x's, so this is a number, and this would be our exact answer. And if I wanted the decimal approximation, we would use a calculator, something like Desmos. But for now, we're going to leave it like this, and if we ever wanted to interpret this number, that's when we would go ahead and bring in the calculators. Okay, so let's try one more, and then we'll call it a video. All right, so we'll be back. I'll clean this up and be back with the next example. So here we are. We're back with our final example, and this one looks a little bit different. You'll notice that we have exponential equations on two different sides of our equal sign here. So on the left I have an exponential equation, on the right I have an exponential equation. So what I'm going to do is I'm going to try and get these two together. So the way to do that, one way to do this is to take one of the exponential equations and divide it over to the other side. So let's take 4 to the x power, and I'm going to divide it on both sides of this equation. So on the left, I'm going to get 3 to the 2x divided by 4 to the x. And on the right-hand side, well, these things just become 1. Right? So I have the same numerator and denominator, so that becomes 1. So what I'm going to do now is observe that I have this x here as an exponent in the denominator, and I have an x as an exponent here in the numerator. And I have an exponent rule that tells me what I can do is essentially pull this out and make it to the x power. Okay, so I have to think about what I have left over. So if I look in my numerator, I had a 3 and then there was this 2. And so what I did is I'm going to take this x and write it out here, but everything that's left over is 3 squared, which becomes 9. So I'm going to write a 9 as my numerator. And then in my denominator, I just had this 4 left over, so I'm going to make this a 4. So by dividing over the 4x to the left-hand side, what it does is it allows me to use some of my tools that I have. So I know a lot about exponent rules, and I can use them effectively here. And so what I've done is by dividing one exponential equation over to the other side, I was able to combine them into a single exponential equation, and now I have a form that I really want. I have an exponential equation on one side, and I just have a number over on the other. All right, so what we're going to do now is I have this 9/4 to the x, and so our strategy before was to just take the natural log of both sides of the equation. So let's go ahead and do that. So I get the natural log of one side, right? So I take the natural log of one side, I take a natural log of the other, and what we get here, right? So I'm going to draw a line, we'll take everything up to the top. So I get the natural log of 9/4 to the x is equal to the natural log of 1. Okay, let's keep going here. Next step, I'm going to take this x and I'm going to bring it down out front. So this is the reason why, right? So this is the reason why I took the natural log, so I can get this x down out of the exponent. And so we get x times the natural log of 9/4 is equal to the natural log of 1. And so to finish this off, I divide both sides of the equation by the natural log of 9/4. And over here, divide by the natural log of 9/4. And what I get is x is equal to the natural log of 1 divided by the natural log of 9/4. Okay, so this is great. This is my exact answer. And I look at this answer and I wonder to myself, you know, if I didn't do any of this, if I just took a step back over at this spot, said, well, 9/4 to the x was equal to 1, I can think, well, is there a number that if I raise 9/4 to some exponent, I'm going to get back 1? And so thinking through my exponent rules, I know that any number to the 0 power is going to be 1. So if I thought about it a bit over here, I could say that I believe that the answer is 0. But if I come over here, x is the natural log of 1 divided by the natural log of 9/4. So let's see if I can reconcile this. Well, the natural log of 1, I ask myself, e to what power gives me 1? And the answer to that question is actually 0. So what I'm doing over here is this is 0 divided by the natural log of 9/4. And 0 divided by any number is just going to be 0. So we went through the whole process, and so we saw our answer, but if we were just clever, we could see that, yes, all right, x equals 0 is my solution here, and we could go ahead and check. So 3 to the 0 is definitely equal to 4 to the 0 because they're both equal to 1. All right, so this is another strategy for exponential equations. All right, so I hope these videos helped out, and I'll see you next time.